I want to thank you for joining me today to talk about Site Recovery Manager implementations and some success recommendations for that. I've already been asked a couple of times, is this focused predominantly on SRM 4.1 instead of 5.0? The answer is yes, it is. Now, it's not a feature focus in terms of SRM 4.1. It's really more recommendations around Site Recovery Manager, business continuity, disaster recovery in general terms. So while it is focused on the way we do things with 4.1, the recommendations I have are really going to be very generic in terms of product set. So they're an approach to Site Recovery Manager, an approach to business continuity and disaster recovery that I think will carry forward for 5.0 fairly well, and I think you'll get some value out of that. Now that said, if you're here for SRM 5.0, I come on again in about an hour and a half, and I'll be talking about SRM 5, and I will not be offended if you feel that you're not going to get value out of this and you leave. So my name is Ken Warneberg. I manage the technical marketing at VMware for our business continuity and disaster recovery products. So things like the Site Recovery Manager 5 evaluation guide, some videos, some blog postings, any of the sort of technical content that both our internal sales staff and field SEs use, as well as material on our website, the stuff that you can download to help you with your evaluations and your material to guide you on your path towards a reliable and resilient business continuity practice. So I'm talking about recommendations for success. A fellow by the name of Roger H. Lincoln said that there are really two recommendations for success. The first one is never tell everything that you know. Anyway, sorry. I read that on Reddit. I thought that was funny. So you've probably seen this slide a couple of times. The virtualization path, where we fit different technologies in terms of our vision of adoption of virtualization as you move towards cloud computing or towards a business focus for your IT, where you can start delivering IT as a service. Site recovery really is fairly unique in that it fits in anywhere, no matter where you are in terms of the adoption of virtualization, no matter how far down the path of an ITSM model or anything along these lines you are. Business continuity, disaster recovery is obviously very critical. So there's no real right time for starting to take a look at business continuity. So with that said, the agenda, the things that I want to talk about today are really a handful of things. How many people have not used SRM at all in the audience today? Okay, so the first section will be good. How many people have a full and tested SRM implementation that you've already completed? Okay, so we've got a pretty good mix of resources. So I'll talk a little bit about SRM, some of the use cases that we've seen our customers using it with, as well as then getting onto the recommendations, onto the implementation. And again, I'm not going to get right down into make sure you edit this config file to point at that particular resource, but really just more approaches in terms of how we look at things like business impact assessments, how we want to recommend that you lay out your storage for easy disaster recovery and business continuity. And then wrap it up with some resources that I think are important that you'll get some value out of, as well as some Q&A at the end. And again, you've probably been told this, but of course, for those of you who have attended VMworlds before, you know this. For those of you who may not, these slides will all be made available afterwards. So if you're worried that you didn't catch something, you didn't write it down, didn't get a picture, I see a few people have cameras, don't worry about it. So Site Recovery Manager, it is designed to help automate the process of disaster recovery. A lot of times with the virtual infrastructure, people try to approach this on their own. Well, I've got copies of my virtual machines. I can take snapshots. I can migrate them somewhere else. But what we don't get from that sort of an approach is the orchestration, the testing, the simplification of that process of recovery. And that's very, very important because we need to, first and foremost, be able to test this on a repeated and continual basis to ensure that our disaster recovery planning is valid and sound, and that when we really genuinely experience a disaster, we've tested it thoroughly and extensively. So we can take what has been a traditional approach to site recovery, which is runbooks. They're literally, in many times, books that contain the steps for recovery. Now that's great, but the problem with a book is that it's very static. Once I've recorded my business continuity plan, my runbook, it's immediately out of date. The second somebody changes an IP or we deploy a new virtual machine or anything along these lines, that runbook is useless to us because it's not tested. We don't know for a fact that it's valid anymore. And the other problem is that we need to train people on this. So I need to have a whole set of staff that have all actually read their runbooks and Yeah, maybe they did that once when they first got hired, but after that they got other priorities. So we need to continually update them, and we need to train our staff on what the process for recovery is. So we can, with Site Recovery Manager, centralize and digitize those runbooks, pull them into one location where we can manage them from a central location, we can access them from one location, and we can update them from one location, as well as testing them. So we turn all of this into an automated plan for recovery. And the setup is important, the failover is important, but again, the testing is absolutely critical to any success, as well as providing audit trails, and we'll talk a little bit more about that down the road. So central management of the recovery plan, and it is layered on top of VMware vSphere. It is not a component that we can drop in irrespective of the platform. It is a component of the virtual environment. So a Site Recovery Manager has a couple of components with it. This is the SRM 4 architecture, and it changes very slightly with version 5 in terms of some additions that we've made to pieces of the architecture. And there are really two components. Obviously, we've got a protected site and a recovery site. We've got vSphere, we've got vCenter servers, we've got, the vSphere client, vCenter server, and our ESX servers. That's the base of the virtual infrastructure. So Site Recovery Manager is its own standalone instance. We need one at both sites, the protected and the recovery. It has its own database, as well as what you see down here, these SRAs. The SRA is the Storage Replication Adapter. So when we're protecting our virtual machines, they reside on a shared storage array of some form that needs to have replication. We do not, with SRM 4, provide our own replication engine. We are entirely dependent on the capabilities of the array manufacturers to provide the protection, the actual replication of data from one site to the other. So we need a means of communicating with those arrays in order to be able to direct it according to the recovery point objectives and the recovery time objectives that we have within SRM. So we have these SRAs. They are written by the vendors. They go through a certification process, and they do a handful of things. They start replication, they can pause it, they can stop it. But really, that is the point of contact into the all-important storage arrays that provide the replication for SRM. So the SRAs we'll come back to in a little bit, but that's a very, very important piece. With regards to the Site Recovery Manager 5, there's a new addition, if you can imagine, some extra pieces that sit on both sides that provide vSphere replication that you may have heard about. vSphere replication is a software-based replication engine for our virtual machines that does not utilize the storage arrays. Instead, we're providing replication at the ESX level, but it's not a replacement per se for storage array-based replication. Instead, it offers an alternative or an augmentation to the array-based replication that we have today. So this is the architecture today. I'll be talking a lot about various components of this as we go through in terms of the recommendations that I'll have. So what is a recovery? I talked about orchestration. I talked about the planning and the process and the setup of our recovery plans. Now, the recovery plan is that digitized runbook. This is that centralized location where we can see all the steps that we have pre-configured for our recovery. When I hit the panic button, or well, it's not genuinely called a panic button, but when my manager hits the panic button, I can run my recovery plan that is the orchestrated and pre-planned process. Canadian, I say process. Live with it. It means process. But so when I hit my recovery plan, it's running through these steps. The recovery plan is really genuinely the central location for everything in terms of the control for restarting our environment. So this is where we dictate how we want to set up our storage, which systems we might want to stop on the primary, well, we have to stop on the primary site if we still have access to the primary site. We can dictate whether or not we want to suspend resources at our secondary site, at a recovery site, because we might want to work in an active data center sort of a model, but be guaranteed that we have resources available during a disaster recovery scenario. So we can specify systems that we want to suspend to free up resources in case of a disaster. So we can get very good utilization of both sites, giving us better return on our investment, but still be assured that we're going to have resources free when we need to run it. And this is also where we see the steps for recovery of individual virtual machines. At what point do we want to start this virtual machine? Do we want to change the IP address on it? Do we want to run a customized script on it? Anything along these lines is going to be managed and visible through our recovery plan. So the recovery plans are absolutely key. And once you set up the infrastructure, you set up your data stores and your protection groups and all the rest of this, this is where you'll spend the bulk of your time. Looking at your recovery plans, hitting that test button that's up there in the top left, and watching the steps for a test recovery. Test recovery is very, very important. We'll talk a little bit more detail about that. But I want to emphasize that testing is, or should absolutely be, completely non-intrusive to your environment. Because these are virtual machines, because we have copies of them, replicas over at the recovery site, we can run tests in our recovery plan that will bring them to life in a completely isolated fashion. We don't need to stop or suspend or interrupt operation of our primary data center whatsoever. We can run the recovery plan in a test mode, which will create an isolated network or attach it to an isolated VLAN, and then run copies of those virtual machines as though we were experiencing a real failure. So why do people use Site Recovery Manager? Obviously, disaster recovery. That's the first use case for this. We've had a problem at a data center and we need to recover. Now, thankfully, disasters are relatively rare, and most of our customers have found that they don't need to use Site Recovery Manager for an awful lot of disaster recovery. So there are a few other use cases that are actually much more common than disaster recovery itself. Data center migrations. If we need to move virtual machines from one site to another, we've taken on a new company or we're moving data centers for any particular reason, SRM is a great way to orchestrate that move. Test it out, plan it in advance, hit that test button to see what it's going to like when we move our data centers, our virtual data centers, and then do it for real in a very, very high level, with a very high level of assurance that it will work because we tested it repeatedly. Disaster avoidance. Scheduled outage for a core switch, UPS upgrade, hurricane that might be looming. I actually did this presentation months ago, so it's not, I wasn't trying to be glib with that, but I'm sure the room would have been far more full had we all of our Eastern representatives here. Avoiding an outage is an absolutely huge use case, probably the #1 primary use that we see in reality. We know that we're going to take an outage on a core switch. That's fine. Most of our environment will be fine during that outage, but we can't lose email or, more likely, payroll. So we want to migrate that to the protected to the recovery site to be assured that it will be available even through that temporary outage. Well, with Site Recovery Manager and the recovery plans, we can get very granular in terms of what we want to create for our recovery plans, and we can have a recovery plan that represents just that payroll application or just our email application, as well as full site level recovery plans. And moving applications for QA. If we have active data centers, we might be doing QA, development work, whatever it happens to be at our recovery site, that need copies or clones or something like that of our primary production environment. So we can take these copies of our real environment and fail over copies of them to as it were, seed or stock a QA environment at the recovery site. So these are the 4 sort of main uses that I've seen with customers for SRM. Audience participation time. Any use cases that you have not seen up there that you are using, or that you've seen that are not up there, I should say. Anyone using it for anything more interesting than that? There you go. Groovy. So, first recommendation, application knowledge. When we talk about setting up protection groups and recovery plans, the absolutely key critical thing to this is that we have full knowledge of what our applications look like in terms of interconnections, in terms of dependencies, in terms of what requires what in order to function at all. Now, the most unsuccessful SRM implementations are the ones where a VI administrator has sat down and done it himself. That's not to say that it can't. I mean, there's absolutely no problem doing that. If you have full knowledge of what your switching looks like, if you have full knowledge of what applications do, if you have full knowledge of what requires what components, many times we do. That's fine. But we're also missing things like buy-in from the line of business owners, from the application owners. We're missing the knowledge that these people can bring to us to help craft a correct-looking recovery plan. If I don't know that an application needs not just Active Directory and DNS, but it also has a dependency on a database server. Perhaps it's a 3-tier architecture, and my web server hits an application server, my application hits a database server. Well, I, as the web server guy, might not know that. So if the BCDR guy comes to me and says, well, what dependency does your web server have in order to run? I'm just going to say, well, I need the application server. So then I take that data, I go back and I create my recovery plan that has those 2 components, and it's missing the 3rd tier because I just didn't have that knowledge of the applications. So the very first thing is absolutely not only get to know the applications and the dependencies, but build a team to help implement an SRM instance. Because that team needs to give their input on every aspect of this, the storage layout. And we'll talk about that in a second. Application interdependencies, upstream and downstream. Who uses that application, and how do they gain access to it? Is it web-driven? That's fine. Are they hitting a hard-coded IP? Are they hitting a DNS alias? What's the time to live on that DNS alias? If we failed over an application and the clients have a very long TTL on the DNS to receive that, a time to live on the DNS entry, even though we failed it over and we've got our RTO recovery time objective of 1 hour and we failed over and everything's successful, but the clients can't connect to that application for another hour because DNS hasn't been updated, that's a failure to meet the recovery time. And our recovery time objective might impact SLAs and might cost money. So it's very, very important to get a thorough analysis of all the applications. Change control can help with that as well. If we have correct change control, we can tap into that as a source of information about what applications use what other applications and what those interdependencies are. If somebody's made a change in an environment, you can go look at that change record and see what was the impact of that, what was the outage, what else did they have to schedule around that change that we made at that particular point in time. So it's a good source of information. Go look at your change control records and logs. And sniffing. There are lots of great tools out there to track what communicates with what on the network. SRM5 has the VIN, vSphere Infrastructure Navigator, is a new component that's come out with SRM5 and with VCOps5 technically. But this tool can help us track even within virtual machines that may not communicate out on the wire, as a sniffer in essence, what virtual machines talk to which other virtual machines on what ports. So this new tool is also a very helpful one in terms of tracking down what our application dependencies are. But the sniffer is definitely a very good place to start. So yes, 3-tier architecture, database, application, web server, Active Directory, DNS. That's sort of a very, very, very basic 3-tier architecture. There are applications that we've seen that have 22 virtual machines with 14 levels of dependency. I mean, that's a lot of dependencies to get in there. And when those of you who are familiar with things like SAP and so forth, you can get some very complex architectures out there with a lot of interdependencies. So scan these things, analyze them, sniff the networks, build all that information up ahead of time so that you understand which applications need to go together in a recovery plan and which ones need to be separate. Multi-tier is very, very complex. So I recommend, in terms of an approach, you don't sit down with SRM and say, great, we bought this awesome new tool, I'm going to now protect the entire environment. Take it application by application. First of all, it's easier to understand the dependencies when you're just focusing on one subset. It's also easier to gain knowledge about the tool and how the recovery plans work and how storage layout is important and all the rest of these things if you're focusing on one small component. So build it out. Take one application, something fairly simple. Build one recovery plan. Make sure that you test it and that works. Then start building out towards the entire virtual infrastructure after we've done that. So when we start talking to the business about what we're protecting with SRM, they don't particularly care that I protected that VM. It's now replicated and it'll recover. When I talk to a line of business owner type of person, they talk about services, not individual VMs. I don't really care what VMs constitute my email application. I care about my service. Is my service protected? Well, what is a service? A service is really a collection of applications. That applications are collections of virtual machines and disk files and all the rest of these things. So build from an application out to protecting a service. Not start with protect the infrastructure and then let's fine-tune it and tweak it and find out what we did wrong and then go back and try to fix it after the fact. Build from small to large. Build it out that way until you're protecting entire services. And then we can start talking about recovery plans that represent the service. I've got my mail service recovery plan. I've got my payroll service. Did I just have a stroke or something? Where was it? So we start talking about protecting services with recovery plans that represent those services rather than individual applications. So then we can go back to the business and justify what we've done with that environment and where we're going with this. I was drinking last night, but not this one. So how can we protect how can we protect it if we don't know what we need in order to protect it? How will we know also what we must not protect? There are definitely things that we should not protect. And I'll come back to that. So business impact assessment. For those of you who have had successful implementations, who's done a business impact assessment? BIA. That is actually a pretty high ratio. That's pretty good. I think there were about 7 people, maybe 10, whose hands went up. That's a pretty high ratio. It's very rare, but it's very, very good to do a business impact assessment. Let me soften it to say it's critical to it's a really, really good idea. So what a business impact assessment is what I was just talking about. Not just crawling all of your applications, but really talking about crawling all of your assets. Pulling in switch information, pulling in application information, taking an asset database and looking through that to see what you've got. And there are a few ways to approach this. You start there and then you build out. You say, what uses this application? And then you start building a tree. That way you can find what your dependencies are. Another way to approach this is to start this from a service perspective. What are our services? And then you crawl down through that to track what constitutes or what contributes to that service. And the key to doing this is interviews. Talk to a whole bunch of people. Talk to everybody in the organization if you think they might have input into what their services require and what they run on. And something that is also very, very critical from a business impact assessment, and the reason why it's called business impact assessment, is finding out the dollar value associated with those things. Not about as many people know their cost of downtime as have done the business impact assessment in this room, I guarantee you that. But when you start talking about these BIAs, we can not only define what the services look like, but define what the impact of losing that service is. And maybe it's something that you don't even notice. If we lose this web service for 2 days, that means I'm going to need to spend an extra 500% next month on marketing in order to make up for the lost revenue. And you get that sort of information from the line of business people, from the application owners that you wouldn't get just sitting there in IT. This then helps prioritize how you go about implementing SRM. This then helps you go back to your finances and say, I need more money for this because if we lose it, this is the impact. And you'll be surprised how often money starts flowing from there. Other sources of information, previous manual runbooks, DR work that people have attempted to do on their own. Look, I made a copy of it and I got a script. That's great. Those things do work, absolutely, but they're not testable, they're not repeatable, they're not something that you can orchestrate among other systems very easily. But they're great sources of information. Naming your environment, names within your environment. So first of all, those SRAs that I talked about have a ton of information. The storage replication adapters have log files that spit out all sorts of info that you might not even think are relevant. They don't just talk to the arrays and set up replication. They log what's going on. So if we experience an error, we can go through and track it. So this is a totally different recommendation. This is recommendation number 2. Take a look at your SRA logs because we have not only information about the arrays and about replication and things that are going on in there, but information about our entire environment. What was trying to communicate with the array. When I set up that protection group for that data store, what was on that data store? All that information is in the SRA logs. SRM logs, of course, have a ton of information. And this brings me to this good naming recommendation. It can be confusing not only in the interface, not only in VC, not only in the SRM plugin to understand what I need to protect. How many people have naming conventions that go a little something like, test 1, 2, 3, Windows Server 1, Windows Server 2. Yeah, it's very common. Or we've got a naming convention that doesn't follow application services or doesn't fall under what we would understand from the business impact assessment. So naming your systems correctly is very important because it helps us in terms of troubleshooting it as well as setting up protection groups, data stores, data store layouts, and our recovery plans. And it could be as simple as just setting up folders in our inventory. I've got local applications, local miscellaneous, and protected applications. Very, very simplistic. But when I look at this environment, when I go to protect something, I know immediately that I've got my protected apps, and all of these things in here are protected in one form or another. So it's a very simple sort of thing that we can do to get more rapid visibility to what's happening. And storage organization. This is one of my favorite recommendations for anybody here. As a vSphere administrator, do you know what's on every LUN? Off the top of your head? No, you have to go hunting for it. And often we have large, and when I say LUN, I don't mean necessarily LUN. It could be any type of data store, I should say. The granularity of Site Recovery Manager is at that data store level. When we fail over an environment using an array-based replication, we are failing over a data store or a set of data stores, a data store group. Meaning, everything that sits within that data store group will be failed over. So when we start laying out applications on disk, when I go to deploy a virtual machine, if I deploy it onto a data store that contains other virtual machines that I don't want to fail over with it, I'm out of luck. So when I start deploying virtual machines and when I start setting them out onto disk, I need to be very, very careful that I'm putting it with or with virtual machines that have a like recovery time objective, because they will all be failed over together. The whole process of SRM is to stop replication, halt access to that data store, mount it on the other side. So if I've got my Active Directory, which you shouldn't, if I've got a database server and an Exchange server sitting on the same one, they will be failed over together. And they will start together unless we go through some other tweaks that we'll talk about. The other thing is the size of your data stores. Now with LUNs, I should say, with LUNs in this case, huge LUNs are problematic for us. Not necessarily for us, but in terms of this data store layout. If I've got a 2 terabyte LUN sitting there and I go and I deploy a whole bunch of virtual machines on that, that's great. I can manage it very, very simply and very easily. But now I've just fallen into that trap I was talking about. I've got all of my VMs sitting together on one data store. Large data stores are great, but use them where it's appropriate. We have to balance the ease of management of our data store layout with the ease of management of recovery. And personally, it's probably because I spend all my days with my head down in SRM, I think this is probably more important, because when we have an outage, it's really, really important that we get back into operations. If I have to spend another 5 minutes a week managing my data stores, I'm going to be okay. I won't lose my job based on that. And sometimes we need to do small failovers. We talked about that core switch. We've got something that's going down, and I just need to fail over one application out of that component. I can't do that if I don't have proper data store layouts that have given me the granularity to set up my protection groups as I need them. So these are some ways of setting it out. We might have a protected site. If I fall off this ledge, it's entirely by design. We might have a data store group that has one LUN that constitutes one data store that holds one application, SharePoint. That's perfect. We might have another one that has 2 LUNs that constitute one data store that has all of our Exchange servers. Perfect. I might have 2 LUNs that represent 2 data stores that I put into one data store group that represents SQL. Perfect. What I don't have is some of my Exchange servers sitting down here with SQL and some of my SharePoint sitting down there with my, whatever it was, SharePoint. Got that backwards. Okay. You get the point. Make sure that they're isolated relative to their use and relative to their recovery point and recovery time objectives, so that we can then craft our protection groups and our recovery plans around that correct storage layout. SRAs. Another recommendation, read the SRA notes. Sometimes sometimes they don't exist, which is unfortunate, but sometimes they are many, many, many pages. But read them, absolutely read the SRA release notes, because there are all sorts of tiny little changes or differences between different SRA vendors and between different releases of those SRAs. I've just outlined some of the things that we've seen in the past, like just little not gotchas, but little differences, things that you might not expect, things that different vendors might implement differently or might implement differently from one release to the next. One simultaneous running recovery plan. At one point, there was only 40 gigs of changes that could be used in a test failover with recovery point. Did they support multiple running recovery plans at one time, simultaneous recovery plans? Some of them do, some of them don't. How they implement a reversal of replication. Do they do it at all? Do they just set up a one-time replication to mirror it back? Do they set up a schedule? These are all in the release notes, and they will all impact not only how we set it up, how we manage it, and how we manage our recovery plans, because the different SRA implementations will dictate to some degree what we can do with our recovery plans. Performance recommendation. Use new versions of ESX. Use the most recent one that you are comfortable with and that is supported. Because it will actually affect things like the speed with which we can do a recovery. For example, deleting vswap files. We can't have the old vswap file there when we mount it and run it on the new side because it's going to contain invalid data. So when we do a recovery plan in 4.1, we have to go through and manually delete every vswap file. That was dog slow in the past. It got a lot better with 4, and it goes away with 5. But this is some of the benefit that we can get by running newer versions. If we're running something recent that just does something like deleting the vswap files faster, or doing SCSI lock offloads with the VAI APIs, there's real benefit in terms of our recovery times. If I can get a better recovery time and thereby a better SLA, and all the rest of these things simply by upgrading to a more recent version, that's a pretty good benefit. Make sure the VMware tools are installed. Why is that? Anyone know why we need that? Sorry? Quiesce the file systems? Yep. With feature replication, that's more important. But with this one also, yes, in order to quiesce them from the array side, if we're doing that, and also in terms of recovery time, we will time out. We'll wait for the VMware tools to respond. If we don't have them installed, we wait till the timeout period. We can override that. We can change the timeout, but then we're getting into other problems like, are we then genuinely going to be able to quiesce the file system? So, yeah. Let me qualify why using larger data stores with NFS is better. Again, we're just not waiting for as many mounts on the recovery site if we have one larger one. And it's easier to do with NFS because we don't have to worry about things like SCSI locks and all the rest of that. Recovery plans, tweaking our recovery plans is probably where most people spend most of their time when they think about tweaking and tuning SRM implementations. Everything else I've just talked about is sort of behind the scenes, things you may or may not have considered. But when we talk about recovery plans, with 4.1, we have 3 recovery plans, priority groups before our recovery, priority groups within our recovery plans, high, medium, and low. So when I put a virtual machine into a recovery plan, I could say it's high priority, medium, or low. High priority runs in serial. So it will start the virtual machines in that recovery plan one after the other, and it will wait until the previous one is finished until it starts the next one. So how many people have used a high priority recovery plan in their real environment? So, yeah, like fewer than I did a business impact assessment. It's fine where it makes sense, but what most customers have found is that impacts the recovery time so dramatically that it's not worth doing it in that fashion. So instead what we start talking about, in medium and low, we'll recover virtual machines in parallel, 2 per host, up to a maximum of 10 hosts by default, so we can start 20 virtual machines in parallel if we're using medium or low priority. So what most people are doing instead is putting everything into their medium priority recovery plans and then just having a whole bunch of recovery plans. So we get the benefit of parallel execution of our VMs in terms of start sequences with the control of having very, very fine-tuned recovery plans. Now, we talked about multi-tier applications to some degree and how it's difficult, and this is one of the ways by which we can alleviate some of the problems associated with that multi-tier. Use the parallel recovery of a medium or low priority, then the recovery plan, but set up multiple recovery plans to represent that infrastructure. Find out what is involved in that multi-tier application. Storage vMotion them to their own individual LUNs or data stores. Then set up recovery plans, protection groups, and recovery plans that represent those different tiers of my 3-tier application. Now I can run all of the virtual machines that represent major apps and then or infrastructure for that 3-tier application. Another recovery plan that represents the middleware. Another recovery plan that represents the web services or whatever it happens to be. So split your multi-tier apps into different recovery plans and use parallel execution on them. That's not always going to be a fit, but it's one way to get a very good increase in speed for recovery rather than putting them all into the same recovery plan and then trying to tweak it using high, medium, and low priorities within it. We end up managing more recovery plans, but guess what? We might be able to use those recovery plans for other tiers of architecture as well. If I say, wait a minute, I can put other things into my database recovery plan. Maybe it's not for that application, maybe not for that particular service, but it's a database for other systems that recovers it around the same time. Well, now I might be able to have a recovery plan that says databases. And another one is migrate to an active-active data center sort of a model. Now, people probably want to do this sort of a thing anyway, but one of the benefits of having an active-active data center is that we don't need to recover everything. We only need to recover what has not been lost from our primary data center. And testing. I talked about testing. So the way testing works with SRM, as I mentioned, is fairly non-intrusive, which is good. We have the capability with when we're running a test plan. So let me back up. When we create a recovery plan, or when we install Site Recovery Manager and pair our sites, we can do inventory mapping. So I can say this network on my primary site will be mapped to this network on recovery site. So when I run my recovery, I'm not going to run it on the same network. I'm going to run it on a different network. I can map resources to resource pools. So I can say I'm giving it full control over the primary site, but I want my recovery apps to run in or recovered apps to run in a smaller resource pool because I don't have the same resource set at the other side. So I can map inventory from one site to the other, changing the way the virtual machines are going to start and where they're going to run when they run on the recovery site. But I can also set up a test network. So I can map where my environment will run when I run it on the test side. And we can do two things here. We can either map the test network to a real network, or like a VLAN, or we can have it automatically create an isolated port group on a switch to run that recovery plan in test mode. So how many folks are using the automatic test network for your, just a few, and that's good. It's fine, again, in certain instances, and I would argue for small recovery plan, for small environments where you're going to be testing very small sets of environments. Spinning up an isolated virtual port group is fine. The problem is that it's isolated. And there are some things that we absolutely should not include. I mentioned things earlier. Things like Active Directory and DNS should not be failed over. So then when we do a test failover, if we've got it sitting in an isolated bubble, how do we ensure that we can actually use those systems? How can we log into them? How can we make sure that everything is communicating with each other, or maybe with other systems that we've got sitting outside our test bubble? And the answer is to use, instead of the auto network, to use an isolated VLAN. So that's a fantastic thing to do. It gives us the ability to hook into other resource sets that wouldn't be included in our primary virtual failover group, but it puts us at risk of doing no harm. So be very, very, very careful. Absolutely use a real VLAN rather than the auto test network, and absolutely get network guys to verify and stamp and sign off in blood that it's not really going to talk to anything else on the network. Because if you fail over to a genuine VLAN, and that clobbers your production environment because it did leak out into the real world, you're in trouble. But yes, through this mechanism, we can do things like tying other physical devices into it. Maybe it needs access to some other network devices. Maybe it needs access to systems that cannot be virtualized, PA RISC or Solaris or whatever it happens to be, real-time systems that you might not have virtualized. This is one way that we can do that. Hook it into a real VLAN for our tests, and then we can be very, very, very sure that when we do our test failovers that we're representing something that is as close to reality as possible when I finish my testing. So that makes it very much closer to successful, or much closer to guaranteed to be successful when we do that failover testing, because now we're assured that it's closer to our production environment than it was before. Okay. Recovery time objective and recovery point objective. So these are the two key acronyms within any sort of BCDR conversation. Recovery time objective, how long does it take for me to get operational again? Recovery point objective is how much data did I lose, in essence. I want to have a recovery point that is as small as possible and a recovery time that is as small as possible. RPOs are actually relatively easy to get. It's just throwing money at the infrastructure to do it. That's easy, right? Yeah. RTOs are a little harder, partially because we can't precisely predict exactly how long it's going to take to start systems. We might have more workload during a failover than we had during our testing, but also just due to the nature of the fact that we are not an immediate failover. We need to start virtual machines. There has been a crash and a restart, and we have to go through that process, that parallel or serial process, to start our virtual machines with dependencies and run different recovery plans. So testing gives us a very, very good idea what our RTOs are going to be, and hopefully you do your tests to drive what you're agreeing to in terms of a recovery time objective. If somebody says, I need a recovery time objective of an hour, you can say, well, I have no idea if that's achievable or not. You can say that with a smile on your face and be completely honest. You have no idea how long it's going to take in order to do a failover. There are lots of reasons for this. Dozens of VMs takes sometimes 45 minutes. Hundreds takes hours. And that's entirely going to be dependent on your environment. There's no way that we as a vendor can tell you what your recovery point is going to be like. It has to be derived from test that gives you real-world data. And there are other things that are very, very key that people often overlook. Preparing storage. When we fail over, we need to, if the primary site is still available, for example, we need to halt replication, shut down the virtual machines, dismount those data stores, go over to the secondary site, mount those data stores, initialize those virtual machines, and then boot them. And that initializing the storage, preparing it, and making sure that it's synchronized, if we can make sure that it's synchronized, if that primary site is still available, that can sometimes add time. If your primary site is still there and your storage is still there, and we've got changes that need to be copied across, and with SRM 5, we've introduced another synchronization step. We do a pre-synchronization, a shutdown, and then another synchronization. That can add time, depending on how much data is changed or is waiting to be replicated. So, preparing the storage can take some time, and this one everyone overlooks. How much time does it take for you to decide that there's been a failover? Who's responsible for that in the room here? Who actually decides that it's time to hit the recovery button? A handful of people, maybe? Is that an easy decision to make? Absolutely not. It takes time to say, someone comes and says, we've had a failure. Maybe it took half an hour for them to tell you. Then you have to say, what do you mean we've had a failure? Oh my God, oh my God, oh my God. Run around and take a look at it yourself. Yeah, you're right, we've had a failure. Oh God, okay. Well, I need more verification before I hit that panic button, because this is going to be intrusive, right? That takes time. That can take a lot of time. And you've been out that entire period. So when you talk about a recovery time objective, do not forget this. Very, very important. Don't agree to an RTO until you know how long it's going to take. Another recommendation, proof of concept, and I would actually expand this and say proof of concept and a pilot. So proof of concept, first of all, proves that yes, this will work. We can fail over an environment. More importantly, it gives you information about how to use SRM. It gives you information that you can then use to start having these conversations about what is a reasonable RPO, recovery point objective, and a reasonable recovery time objective. When you start doing a pilot, you can then go to those line of business people, the application owners, and say, we failed over this application, it took this long, and I can get you recovered in this amount of time. Remember when we did that business impact assessment and you said, if we went down, I'm going to lose my job? Well, now we can get you operational again in an hour and a half. Would you be willing to spearhead this conversation with the other guy that was not willing to invest in an SRM or in the cost of replication or whatever it happens to be? So we can get better support, and we can also learn in this controlled environment without eyes peering over us and saying, how's that SRM project coming along? And if you do that with help, there are lots of little things that can go wrong. Installing SRM, because I've done it a lot, it seems fairly straightforward to me. That's easy. The difficult part comes in that data store layout. It comes in what should my protection groups be. It comes in what should I put in what recovery plans. That's not something that's intuitive and easy to kind of run through. Getting somebody who can help you with that, who's seen some business impact assessments, can dramatically reduce the amount of time that it takes for you to get SRM going. And it's a very important piece. The thing that I see go sideways most often is the SRAs. And it's not because the SRAs are done poorly or anything like that. They differ from implementation to implementation, but it's the last place people look. They try to do something and they see SRM has a failure. So then you spend a lot of time browsing through the SRM logs. Then you spend a lot of time browsing through the VC logs. Then you take a look at your ESX host and say, am I out of resources? And then you look at your storage and say, everything's looking good there. The SRA logs themselves have a ton of information. Who looks at that on a regular basis? Very few people. So knowing when something goes wrong with your proof of concept or your pilot is the job of somebody who has done that before, consulting or a partner in that space. So I very, very strongly recommend that. So I'm going to very quickly talk about some of the resources that we have available to us. Again, we talk about the main website and the pieces that are there. Some of the partners that we have that can help you out with these things. I love this one, the VMware availability blog. There are a couple of postings on there by a very, very intelligent and good-looking, wealthy, really that sums it up guy. His name's Ken Warnerberg, but that's me. That's my blog. Upgrading to SRM 4.1, I have written a evaluator's guide for 5.0 that will be released very soon as well, probably contemporary with the release of SRM, which is due early September-ish. I've left these mostly in there for reference purposes when you download the guides later. There's an SRM book by Mike Laverick. Don't suppose Mike is here because he probably could have given this presentation. It's actually free for download. You can purchase it as a real book, or you can download it for free. An excellent resource in terms of getting some information about SRM, as well as a handful of other things. And he has a new book coming out December 11th that is specific to Site Recovery Manager 5. I've got another session, which is SRM 5 features and some recommendations around the implementation of SRM 5, as well as some demos that we've got down in the booth there as well. And that is pretty much it. I will take some questions here. We've got a little bit of time left, so I'm quite happy to do that. One thing I would also like to say is that we've got not only... this is not the slide I was after. This is the slide I was after. When you receive these decks later on, please, please, please fill out this survey. It will actually genuinely affect the direction that we take in terms of product management and development of SRM. You have direct input into that. So thank you very much. I'm very happy to take questions. We got about another 10, 15 minutes, so thank you for your time.